Thank you, Vittorio. Thank you, and good afternoon, everyone. So I hope you enjoy the pun in the title, because it reveals the purpose. My purpose here, the purpose is to survive as software developer in this LLM era. It's not a gift for grant. So my name is Luca Rainone, and I'm a software developer. I am a freelance, so I collaborate with many companies here in Bolzano, but also outside, abroad. I am a CTO ad interim on a startup here, Nanea, and I had to learn a lot of code and use a lot of languages, frameworks and languages that I know, and frameworks and languages that I don't know. My customers and companies know that I don't know, but I had to take the opportunity to use the LLM in various contexts. So I started to refine my approach to the new software development in the LLM. And my attitude is to work in vanilla flavor, you know, vanilla JavaScript or vanilla PHP or whatever. And I did the same with the LLM, basically because I started before Cloud API. So I started to do my own CLAI that helped to me to create good prompts and avoid simple copy and paste for programming. Why? Because I wanted to work with LLMs without layers, without hidden layers. So I would like to understand the power and the limitation of LLMs without layers that can hide this kind of tricks for LLM. I discovered a lot of things that are some surprising, but the main thing is that I made a lot of mistakes, primarily at the beginning, for example. At the beginning, I made the same mistake of maybe all developers. I treated the LLM like an autopilot and not like copilot. They are marketed as copilot, but I started to use like autopilot. So, okay, this is the track, this is the main idea, please go write your code, I come back where you're done. Of course, it didn't work, and you know that it doesn't work. But here is the gap. It's called the knowing gap. We all know that this approach doesn't work, but it is not enough, because we need to internalize this concept. It's like everybody knows that smoke is bad for everybody, but people still smoke. People still do. So there is something of more. We need to internalize better this concept. So I started to put in line all my talks, all my experiments, and then why I'm here. I just create my puzzle, and then I share with you all my talks, put it in line. So we always heard about the human in the loop, but what does it mean, human in the loop? For example, there is the first approach. That was the first one. So let LLM generates code, and I'll review it. But who likes to do code review? Raise your hand. Nobody? Nobody. Nobody wants to do code review. So, but even if it works for you and it is fine, maybe it's not scalable, it's not efficient. It's a good approach for some tasks, and necessary, of course, for some tasks, but of course it's not scalable. The same is the reverse. So I write the code, and then I ask the LLM to review the code. This is exactly the same human in the loop, but it's a totally different approach. And this could work for me, could work for everybody else, but it's still not, maybe not efficient, because you have to write your code, and we are slow as developers in the end. And then there is a third approach that maybe it is better to use. it is like agile development, so small loops, small interactions, small input, small output, test the output, and go ahead on the software development. This is maybe not the faster way, but for sure maybe it's the more efficient way, because it gives you control, it gives you power of your code, so you are able to debug the code that you ship on production. That is not given for granted. So the core goal is to work together with LLM and don't overwrite. The core goal is to create tasks that work for me, for ourselves, that could be different for you, and make tasks that are complementary, not a task that I have to double check. It's not efficient, and it produces bugs because sometimes looks good to me in the end. So how we can do this? I take a lesson from the aviation. I read the paper, the protocols from aviation, from pilots, where they have to make a pre-flight checklist. And there are no double check of all tasks. Not all tasks are double checked. Simply the tasks are complementary. The pilot asks to the copilot to check one instrument, some tool. The pilot has in the task to give the feedback to the pilot. The pilot agree and mark this task on their own. There is no double check, but there is complementary. We should do the same with LLM. How? It depends by all of us. So my thoughts is, okay, we are now, there is the human, there is the LLM, but don't forget that there are still the good old algorithm, the good old CPU. And we need to take the best of these three actors, the best of the human that could be different from everybody. The best of LLM, the LLMs can summarize, can extract labels, can interpolate, can do a lot of things, but still the human is maybe more creative and could be breaks the mold. And in any case, the human can know his customers for the product, can know the boss, the employee, the colleagues, and everyone. The things that the LLM cannot do. So we can maybe try to take the best part. And then don't forget the good old algorithm. When we require to produce a large output, maybe want to test some code base with one click, maybe we still need to use maybe a script or test, unit test, end-to-end test. And putting together all these pieces, we can maybe build a flow that can work for us and for the product. This is basically the same thing. We still need to cover all the graph, and the algorithms are always the more reliable, the deterministic part of actors, and we need to take in consideration this part. We need still, as a human, as developer, it's our job to work together with the LLM and produce also the scripts and the algorithm and test. So, asking the LLM and to generate thousand line of code, it's forced to me to say, it looks good to me. There is no alternative, at least for me. So we need, in any case, we need to ask the LLM tasks that we are sure that they are, the LLM can produce without errors, and or it should be possible for us to test it without much effort. The best would be with maybe a unit test or end-to-end test. Another thing that I discovered when I tried is that languages like prompting with JSON, YAML, and XML these are languages more authoritative for LLM. There are also papers and research that agree on that. with small difference with models. But the best part is that YAML and XML are also human-readable, developer-readable, let's say. We can read easily a YAML and understand immediately what is the context that we are giving to the LLM. And then we need to ask the LLM to give an output that we can parse, we can test with one click. Maybe also that we are able to do a code review, but with a reasonable size. Another thing that I discovered, it's quite surprising, it's that it's not necessary to give the source code of a previous generated code that I asked to the LLM to generate in a previous session. It's not needed to give again the code. It's enough to inject the prompt that I use to generate the code. For example, I asked to the LLM to generate 20 functions utility, and then I want to use this function. It is enough to don't give it the source, but just the prompt that I used. And it gets the API definition of all the function. This is work that I would not suggest because maybe it's dangerous, but maybe in some context could be a good idea. So this is, for example, an example that I meant. I mean, when I created my my CLI, I had like Cloud Code in the end, you have different files. And here, for example, I put my convention of the database in a YAML format. In this case, it's quite easy to read, human readable, and are very specific in this case. And surprisingly, the LLM is able to understand. For example, if I want the table name in singular rather than plural, this is not a topic of singular versus plural, it was enough to do something similar, and it worked. So I started to use my convention, my prompt convention system prompts in this way, and it seems to be more efficient. More efficient, I don't say that is token efficient or whatever, efficient in general. When I ask the LLM to produce code and I give all these pieces of puzzle, I'm able to generate a software with a good quality. This is another example, this time in XML. These are injected in a main prompt, for example, and it could be also inside a markdown file, and block quoted with a backtick, so I had also the syntax highlighter of the IDE. In this case, I enumerate the paths that are in the project, and I explained all the paths, and the LLM is able to understand where to put the files when I ask it to write a module or a feature or whatever. Also, this one, this is not a formal, this is just invented just for my readability, but the LLM was able to understand. So when it was the time to use this environment variable, he knows that all these vars are prefixed with LLM move. That's the name of my CLI that can use. Now I can say that there is the revenge of test-driven development, because if I started to use the test-driven development, so it's more easy to test the output of an LLM in this case. And so I'm not forced to do code review, but simple, okay, this is what I want. I don't give the context of the unit test of the test, but simply I just run the test, so I can be sure that their output is what I wanted. So basically the summary is this. In general, as a rule of thumb, Never ship the code that you are not able to debug. Sometimes it happened also to me. And in general, when I read the code wrote by the LLM, I'm like, okay, this code maybe I could write to myself. And it is good because in this case, I'm able to read and understand the code. But everything begins with an input, so make sure it's a good one.